So in this video, I'm going to recap binomial probability, and I'm going to start by defining what a binomial experiment actually is. So a binomial experiment consists of n repeated trials. So that means that we're going to repeat the experiment multiple times, and the number of times that we do that is equal to n. The next point is that each trial only has two possible outcomes, which we're defining as a success and a failure. So the example we're going to do in a moment is flipping coins. So here you might define a success as obtaining a head, and obtaining a tail would be defined as a failure then. The important thing to note though is that there's only two possible outcomes. If you have any more or any less, then it's not a binomial experiment. And that's where the bi comes from in binomial. Bi means two. Alright, so the last thing is that the probability of success is the same for every trial. So that means in the coin example, every time you flip the coin, there is a 50% chance that it will be a head and 50% chance it will be a tail. Those probabilities don't change at all based on anything else, such as the number of times that you flip. Alright, so let's move on to the equations for which we can use to calculate probabilities. So, the probability of an outcome occurring is defined by this equation here. So P is the probability and X here is the outcome that we're looking for. And I've defined the notation down here. So X is going to be the number of successes that we're looking to achieve. We've then got this CXN thing, which I'm going to come back to in a moment. Pi here is defined as the probability of success. So if you're flipping coins, the probability of you getting a head, which you can define as the success, would be 0.5. X again is just the number of successes, and 1 minus pi you can calculate from knowing the probability of success. So the only other thing is n, okay, and this is the number of trials. So the number of times that you perform that experiment in a row. So we're going to do an example over here in a moment where we're looking for the probability of obtaining 6 heads when flipping a coin 8 times. So let's go through and write out what each of these values is. So n is the number of trials. So that's going to be the number of times we perform the experiment, and we're flipping this coin, which is the experiment, 8 times. So n is going to be equal to 8. Next up is pi, which is the probability of success. So we're going to define the number of heads that we want as, heads I should say, as the outcome of success. So therefore the probability of obtaining a head is going to be 0.5. And the number of successes, or the number of heads that we're looking for, is going to be equal to 6. So that's the 3 things that we need to be able to fill out this equation. So let's go ahead and do it. So the probability of x, which is 6, or you can write 6 heads, is equal to C and N and X, so 8 and 6. Usually the notation you just fill in like that. Oh, sorry, we know pi, it's 0.5, so times 0.5 to the power of x, which is 6, times, this is 1 minus pi, so 1 minus 0.5, and it's to the power of n take x, so 8 take 6. So how we can get this out, this n stuff can all go in a calculator, but this first thing, that is basically a calculation that's trying to get you the number of combinations which produce the same outcome of 6 heads. So for an example, one combination that would produce 6 heads out of 8 flips would be, say the first 6 are all heads, and then the last 2 are tails. Okay. Another combination might be that the first 2 are tails and then the next 6 are heads. Okay. So there's going to be a whole host of different combinations in terms of the order that you get the heads and the tails in, which produce the same outcome, which is a total of 6 heads. So that is what this section here is calculating. Just mark that in here. So this C86 thing is going to give you the number of combinations of 8 flips that produce 6 heads. Now, if you want to calculate this, one way is to use this equation, okay? What this is the little exclamation marks are factorials. This is a thing in maths. So, as an example, if you had 3 factorial, that would be equal to 3 times 2 times 1. So, that would be equal to then 6, Okay, similarly, say you had 5 factorial, that would be 5 times 4 times 3 times 2 times 1, and whatever that is, it's 120. But anyway, that's what this is calculating. So if you want to do it manually, that's the approach that you need to take. Otherwise, if you're using Excel, it's like an inbuilt function. So let me show you that instead. So if I jump over to Excel, so equals to start your function, and then the name of it is called combin, and then it's asking you for the number and the number chosen. So number here is equal to the number of trials. So we had 8 flips for that, and the number chosen is basically how many successes that you want. So we want 6 heads or 6 successes, so that's all we need. Type that in and hit enter, and we'll get 28. Okay, so that's the number of combinations of heads and tails that will give us 6 heads overall. So jumping back, we can simplify this to 28. So it's then just by 0.5 to the power of 6, and 1 minus 0.5 is 0.5, 8 minus 6 is 2. So now we just need to type this into a calculator, and you get about 0.109 approximately. So that there is the answer to our example. So there's about 11% chance of obtaining 6 heads when we flip the coin 8 times. Alright, so that's pretty much it in terms of calculating the probability of a certain outcome when you have a binomial experiment. So the only other part that I wanted to point out was you can calculate your expected value quite easily for this type of experiment. So the expected value, EX, alright, is equal to N, which we said was the number of trials, multiplied by pi, which we said was the probability of success. So the example that we're going to do here is what is the expected number of heads when flipping a coin 8 times. So in this one, the number of trials that we need, N, that's going to be equal to the 8 times that we flipped our coin. And the probability of success, that's the probability of getting these heads. So we already said, that was equal to 0.5 because there was 50% chance of heads, 50% chance of tails. So substituting into our equation, so E of x is equal to n times pi. So the expected number of heads is equal to 8 times 0.5, and that gives us an answer of 4. So that's pretty much all there is in terms of the equations for binomial probabilities, and please check into the other example videos for further illustrations of how to use them.